All right, guys, welcome to week 2 of distance learning. I hope you guys are doing great and being safe. I want to thank you guys both, every one of you, for watching the videos from last week. I really appreciate it. So continuing our distance learning, we are going to introduce/review something new this week. And so I will be recording myself doing a couple practice problems. I'll try to do 2 today. And then I will upload an assignment on quizzes for you guys. And so I have something special in my hand though. Oops, it's right here. Before we get started, I want to just have a little fun before we go straight to business. But as you can see me, the distance formula is right behind me. As you guys probably remember, last semester, after Thanksgiving break, it was my tradition to do a dad joke every single day until Christmas break. And I've done this not only last semester, but the past couple of years as well. Usually, my tradition to celebrate towards the end of the year was to give you guys a dad joke every day past spring break. So I realize I'm just a little bit behind. So past spring break, this is technically day 6. So what I'm gonna do before we do the distance formula, I have 5 dad jokes for you guys to cover every day last week. And then obviously I'll have 5 more for you guys for every day this week. So I got 5. Are you ready? I'll try to be in my comedian stance. You guys might have heard these before, but I hope you enjoy them. Where does a dog go when he lost his tail? A retail store. Haha, get it? Little cubby? Yeah? Do you like that one? Okay, you wanna help me with the next one? Here we go. I actually really like this. A lumberjack went into a magic forest to cut down a tree. Upon arrival, he started to swing at a tree when it shouted, "Wait, I'm a talking tree!" The lumberjack just grinned, and you will die a log. Number 3. If I have twin daughters, I'll name one Kate. The next one I'll name Duplicate. 2 more. My wife just stopped and said, "You weren't even listening, were you?" And I thought to myself, that's a weird way to start a conversation. Last one has to do with math. While most puns make me feel numb, math puns make me feel number. See, guys, it's not the same without having you guys in here to smirk and cringe, but I'm hoping that you're smirking and cringing at your house. Okay, all right, the distance formula, here we go. It is this kind of intense looking formula. It's very similar to the midpoint formula, but obviously there's some key differences as well. It's similar because we're both using x values and y values just like we did with the midpoint formula. Now we're using x values and y values, plugging them into what's called the distance formula. As most of you guys can probably figure out because you're very smart, the distance formula is what tells us the exact distance between 2 points on a coordinate plane. All right, so here we go. I'm going to move this over. We're going to do a couple examples. Move that over there. Let's see if you can see this. I'm going to break this down just a little further. All right. Distance, that's our D. Distance equals, and now notice above the whole thing, there's this big square root sign. That means at the very end, no matter what, we have to take the square root at the very last step. So whatever number that we get when we do these, we have to take the square root at the very end because that tells us our distance. The reason why, and some of you guys might figure this out, the reason why we take the square root is because the distance formula is actually related to and almost a cousin to the Pythagorean theorem. All right, the Pythagorean theorem is something big time in geometry where you have a squared plus b squared equals c squared. I'm not going to derive, how we can get the distance formula from the Pythagorean theorem. Just know that they are related. It's because essentially the Pythagorean theorem is also finding distance almost in a triangle. So anyway, okay, d for distance equals the square root of the whole thing. Here we go. x2 minus x1, all right? Don't be confused with the 2 and the 1 right here, these subscripts, just because this just designates that we're using the second x value. This designates that we're using the first x value. Okay, so second x value, first x value. Once we plug in our values, those two numbers go away. Now, this number right here is an exponent. It's not a subscript. That actually matters, right? So whenever we do this operation right here, order of operations, we have to do parentheses first. Whatever number that we get, then we have to square it. And square it, because that's what that 2 means right there, means you're basically multiplying that number by itself. And I'm sure you guys already knew that, okay? So we have an operation we're going to do right here. We're going to square it, and then we get a number. But we're not even close to being done yet. Notice that we have an addition sign right here. That doesn't change. And then we have to do the same thing with our y values. Please make sure that the x values stay over here, y values stay right there. Kind of similar once again to the midpoint formula there. We're using our second y value. We're using our first y value. Notice that the original part of this formula, there are minus signs in there. So if you put in a subtraction or a negative number in that second number, it's going to cancel out. And I'm going to show you guys an example of that. That plus sign doesn't change at all though. Never changes at all. So once we do the same thing with the y's, we square it, we're going to get a number here, we're going to get a number here, we're going to add them together, and that's when we take the square root at the very end. Okay. Obviously, I'm going to pull that whiteboard back and work out an example for you guys. So I've had a graph right here, makeshift coordinate plane. Let's just say we have 2 points, and since it's diagonal, we can't really count the boxes to see what the distance is. If we have a coordinate point right here and a coordinate point right here, well, that's exactly what we're going to be using with our distance formula to find the distance between those 2 points. Notice that with the midpoint formula, midpoint is in the middle. We're not using the midpoint formula. We're using the distance formula. It tells us the distance between 2 coordinate points on a coordinate plane. Okay, move that back over. All right, let's see. Okay, I'll try not to be in you guys' way. All right, here we go. So we have our distance formula again here. Notice that we have 2 coordinate points. This is, the coordinate points are just listed out. They're not on a coordinate plane right now. So I'm going to, just kind of similar to what I did with the midpoint formula, I'm going to underline my first x value, and I'm going to underline my second x value. Because remember, in a coordinate pair, x comma y, x comes first. Okay? And now we're basically just plugging it in. If 7 is my first x, or my 3 is my second x value, I'm going to plug it into the formula. I want you guys to know, I'm not going to go into huge detail about this, but if we used 3 for our first and 7 for our second, it doesn't matter the order of the first and the second. You're going to get the same thing no matter what because of the square. Okay? The important thing at this point is making sure that we use the x values into this section right here. Okay? So it doesn't matter which one, the 7 or the 3 that we use first. I'm going to plug it in. Here we go. My square root is still there. So I have my second x value, which is technically 3, minus, I'm going to drop down that minus sign. My first x value is a positive 7, so that does not cancel out. That minus sign does not cancel out. And I cannot forget to square it right there. Okay, so well, I know what 3 minus 7 is, right? 3 minus 7 is negative 4. Negative 4 squared, well, negative 4 times negative 4, 2 negatives make a positive. That is a positive 16. Okay, sweet. So I just kind of simplified those x values right there. I'm going to drop down that plus sign because that plus sign in the middle never changes. Okay, all right, here we go. I'm going to not do that. Oops. I'm going to now do the same thing with my y values. All right, so I'm going to kind of, circle my first y value. I'm going to double circle my second y value and just plug those in. So if my second y value is 6, put that in right there. That minus sign drops down. Oh, my first y value is positive, so once again, that minus sign does not cancel out. 6 minus 3 is 3. Don't forget to square it. 3 squared, which is basically 3 times 3 is 9. Here we go. 16 plus 9. Oh, I know what that is. That's 25. Now, is 25 my final answer? No, it's not, because once again, we have to take the square root at the very, very end. So square root of 25 is 5, positive 5. Okay, you can also use a calculator to find the square roots of numbers if you don't have these memorized. There's a lot of times in the distance formula to where it's not going to be a perfect number. You have to round. You'll get decimal numbers, and that's okay too. My next video and next example, I'll show you a decimal. All right, so I'm already at over the 10-minute mark. So what I'm going to do for my second problem, I'm going to do another video. So this one's not super long, and I'll upload both of them to the Google Classroom for you guys to watch. Okay, just to recap, we used our distance formula, and what I want you guys to do is write this down. You can find it online. Write it down exactly like this. And then once you have 2 coordinate points, I have a 7, 3 and a 3, 6. I can use those to plug into my formula, right? I would recommend just doing the x's first. You get a number. Do the y's next. Once you add them together, you take the square root at the very end, and we get, in this example, 5. So that tells us that if we have some point, here we go, 7, 3, so this is just a rough drawing. 7, 3 is about right there, and then 3, 6 is about right there. Between these 2 points, the distance is exactly 5. So that is what that means. If we have 2 coordinate points, we can use the distance formula to find the exact distance between those 2. Okay? All right. Thank you guys for watching. I'm going to do a second example now to where we get a decimal number and a couple negatives as part of our coordinate point.